So we are going to start recording. So this is Dr. Jensen here. So the lab portion of the class, we will have at least some meeting every week in order to go over the labs because they are not all super self-explanatory. So the first lab we're going to do or talk about today is very easy. It's just kind of an introduction lab. So but before we get to that, I have a quick PowerPoint we need to go through real quick for what am I looking for reports. Okay, so you probably would have seen the PowerPoint listed on my page when you get to the thing. So your class essentially mimics my ELI class or my 111 class. So I am teaching a 111 class right now. So if you are finding that you don't have sufficient videos on your coursework, or you want other videos that are more or less more boring than what you might otherwise find, I have plenty of videos that I'm doing now, so you can always find my videos that I can post a link for in the on the page as well. So you guys have extra resources because you're in 111, and I am currently teaching a 111 class online. So I know that the ELI stuff is usually a lot of just self-taught, but I have lectures that I do every day, so I have those available. And so if you want them, they are there, okay, for you. And so I can post a link for that later. All right. So let's start off by looking at. All right, so if you have not done the survey, okay, you should consider doing the survey. Right now, it's looking like we're still the majority. I mean, the votes are all over the place. So what I may do is do a second one to narrow things down a little bit more after I kind of get a first go round of preferences. It is looking like Saturday morning is still going to be our preferred time for meetings. So this is still looking to be the preferred time, at which point I will still do the recording, and there will still be a Zoom recording of every lab, okay, which I will post in the lab section underneath each lab, okay? So, but before we get to that, we got to look at the lab reports and what I want you to submit, okay? So each lab that we do, you're going to do a formal lab report, okay, which means you're writing up the lab with, it will probably be in Word for the most part, so you'll transfer stuff as much as possible to a Word document and basically write up the report of what you did, okay? This is the lab report format, okay? This is the important section here, okay? So every lab that you submit, with the exception of the pennies lab, okay? The pennies lab is not a full lab report, okay? And I will reiterate that when we get over to the penny section. So it's not a full lab report. It is just an abbreviated one to kind of look at the stuff that we did. Did you catch this information? Okay, so after this, name, title, the purpose, procedure, there are pre-lab questions usually, your data section, and a conclusion. Okay, you will put these into a Word document, type all that up, and then you will submit that via the links on the Canvas site. Okay, so there are links either on the calendar or on the lab page. At the bottom of the lab page, there are submission links on the lab page. Okay. All right, so the purpose is something we'll talk about with each lab. So every lab, there is a purpose to doing every experiment, okay? Every experiment that you do has a purpose. It is not always the stated purpose or objective of doing the lab, as you'll see in some of the handouts. So in some of the handouts, you'll see, like for the physical properties lab, it states the objective of doing the experiment, which is not really the purpose of doing the experiment. Again, the purpose of doing the physical properties lab, which we'll talk about next week, is to determine the concentration of an unknown. But their stated objective in the lab is more like learning how to use glassware, understanding how to take densities. Like, that's not why you're doing the experiment. Okay, so each lab, apologize, is that I have a 5-year-old pup, or a 5-month-old puppy who's, you know, up here with me because he's a little troublemaker. So I apologize for any interruptions. You'll probably see him at some point. So the stated purpose of doing the experiment is not always the stated outline or objective of each experiment, all right? So we will talk about the purpose of doing the experiments every week, all right? All right, so the procedure. So for most of the labs, you have a handout, okay, that is a PDF outline of the procedure that you need to do, okay? The only thing that I don't want is my PDF document given back to me or C lab handout, okay? You need to have written up a procedure section, but how you do it, I don't care. You can bulletize it, paraphrase it, plagiarize it, whatever you got to do to get the procedure section from whatever you've been given into a Word document that is not my handout. I just don't want to see my documents given back to me, okay? So that's pretty easy, right? The procedures are generally given to you, right? So you just, the only thing is since we are going to a virtual, since all of these are virtual labs, there are changes to the procedure section. So obviously, like the physical properties lab would be a lab that we would do in the lab, right? So the procedure is written as if you were doing it in the lab. I'm just giving you the data that goes with it. So we're skipping the actually doing the experiment, but you have the data in order to do the lab report part, okay? So you still need to have the procedure in there as if we had actually done it, okay? Now, most labs have pre-lab questions, okay? This particular lab does not have pre-lab questions, but most of them do. Again, you will answer the questions and include it with your lab report. You do not have to do the pre-lab questions before the lab. You do not submit the pre-lab questions in a separate file. These are part of the lab report. Okay. Your data section for most of these are virtual labs, or obviously all of them are virtual labs. So in most cases, you will either be given data, okay? So you just need to probably finish the data section. A lot of times I'm giving you just the data that you would have collected in lab, okay? So for the physical properties lab, for example, when we go into the lab, we would weigh a 1 milliliter volumetric flask, empty, and then we would put different solutions in there and get weights on them full, okay? So I would give you the weight of the flask empty and the weight of the flask full. Then you would do the subtraction and do the calculations to get the weight of just the solution, okay? So I'm giving you all of the data. You just have to finish out the data set, okay? Again, there are standardized data tables. So for the most part, I just don't want my PDF like scribbled on and sent back to me, okay? Remake the data table in your own report sheet. All right, the conclusion is really where the important part is, okay? And that's where we want to spend just a minute of time focusing on this, right? Because that is the purpose of really doing the pennies lab, is to focus on the conclusion, right? What does the data mean, right? There are different ways that professors talk about this, whether it's a discussion section or a summary or a conclusion, and generally these aren't synonyms, okay? They generally have different context or connotation of what the professor is really looking for, okay? In this case, I am looking for you to summarize, okay? The conclusion is a summarizing activity, but it also includes analysis, okay? What does the data mean, okay? When we're in the lab and you're using beakers to weigh out solutions and pieces of glassware, and we're pipetting different things. All of these pieces of glassware that you would write down volumes of, I transferred, 50 milliliters from this flask and I pipetted 50 milliliters to this flask, and I diluted it to 250 milliliters over here. You're going to have, sometimes we collect a lot of data, but not all of that is important, okay? You don't need to know, for example, the example that I usually use is like getting a blood test done, okay? You don't need to know how many microliters of blood your lab technician used and that they put it into some XYZ piece of equipment or centrifuged it at such and such speed. Like you don't need to know any of that, okay? If you got a blood test because you're getting your annual cholesterol check, you don't need to know at what RPMs they put the centrifuge at, right? That's not an important piece of data, okay? So there's a lot of data that we often collect that's not important for the purpose of doing the experiment and not important for our customer, okay? So when you write these lab reports, you should be always thinking in the frame of mind of what is my customer paying for? What does my audience need from this information? Okay. A lot of these labs are honestly set up very similar to how we used to do things in an analytical lab. Someone brings in a sample, we run the test, we write the report, we tell the customer what it was. Okay. So for example, the physical properties lab is very similar to kinds of experiments we do in environmental labs, where we know something exists in the sample, right? If I know I have lead in my drinking water, okay, I'm not paying you to tell me I have lead in my drinking water. I already know it's there, okay? My question to the chemist is, what is the concentration of the lead in my drinking water? Is my drinking water safe? Okay, now, obviously this opens up issues of like whether or not any amount of lead in our drinking water is safe, but that's generally only because people don't understand toxicity is a function of dose and things like that, nothing we drink or eat is pure at this point. And so there are always levels of what is healthy, acceptable for your entire life to consume, right? So, but that's what you get is the analysis part, is someone saying, you have 4 ppb of lead in your drinking water. This is considered by the EPA standards to be a safe level to consume. That you don't require, that you can take XYZ steps, but you shouldn't need to. That over your lifetime, this will have no impact on you. Okay. So when you write the conclusion, okay, it's a paragraph format, right? It shouldn't be more than a paragraph. Okay. I'm not looking for a page of writing here. Okay. If you are doing a page of writing for your conclusion, you've missed the point of summary. Okay. We're supposed to be working on brevity, okay? Being brief, being concise, being poignant, okay? Driving home, what is the purpose of doing the experiment? What did you find? And what is the result? Okay? So when we write for lab reports, generally the tense is third person objective, which means don't use I, me, we, us. Refer to yourself in the third person, okay? We're taking ourselves out of the writing, okay? It is not about how we feel about the experiment, what we did with the data, okay? So we want to make it more objective by removing ourselves from the writing, okay? We should be writing in complete sentences, okay? I don't want bullets, I don't want fragments, okay? This should be well-written, constructed sentences. Okay, your conclusion should focus on what was the purpose of doing the experiment. Okay, so here's my main advice here. Okay, these 4 steps. Okay, these 4 steps are generally the advice that I give for report writing. Okay, what was the purpose of doing the experiment? Okay. Every experiment has a purpose, and the purpose is not to learn how to use glassware. Okay. If you go into your doctor and they draw blood, and your nurse tells you this is, she's learning how to draw blood. Okay. That's not the kind of thing you want to know from your nurse, like when you're trying to give blood, right? That you're the first time she's ever drawn, or he or she has ever drawn blood. Okay. That doesn't inspire confidence. Okay. That's not the purpose. That's not why your doctor took a blood sample, is to let people practice on you. Okay. That's what they do in school, right? You don't go to pay for that, right? So there is a purpose of drawing blood. The purpose is to analyze something with regard to your health. Okay. The methodology is a brief statement of how they may have gone about doing it. They took your blood, they ran it through a centrifuge, they ran XYZ test. Okay. It is not a regurgitation of the procedure. Okay, so that's the one thing we got to watch out for in the methodology section is I don't want the whole procedure regurgitated. Okay. Again, we are picking the important parts. And so that's kind of the learning aspect here, is learning what parts are important. Okay. After we ran XYZ test, what was the most important result from that pertains to the purpose of the experiment? Okay. If I'm drawing your blood to test your cholesterol number is the most important number. Okay. The other readings you may get off the instrument are not important. Okay. What was the barometric pressure and temperature and things like that that the blood sample was at the time? Okay. Those things aren't important. Okay. Now, for some of our experiments, there won't be a fourth step. The fourth step is the important step, really, is the analysis, where you've got your printout of your blood test, and you go back to the doctor, and your doctor tells you, okay, these numbers are high, these numbers are low, because of the relationship of this number that seems really high and this number that seems really low, you are likely having, some sort of blood issue. You have, a kidney issue, or you have a liver issue, or you have, some anemia or something else that's indicating, that you have some sort of underlying health issue. Okay, that's the analysis part. What does all that data mean to me as far as my health? Okay. Our data for most of these labs is not going to have some further analysis that you really need. Okay. Now in 112, we do a hard water analysis. So we do a water analysis for calcium and magnesium. So in our household, we have, water that comes out of our tap. Sometimes it has extra calcium or magnesium in it, and that can lead to things like, soap scum buildup and calcification of your pipes. And so, so we can analyze the result to mean there is some further analysis, or what does that number mean? If I tell you that you have 50 ppm of calcium in your water, that's the result. Okay, but what does that mean? What does 50 ppm of calcium mean to me? Like, does that mean I should start using my Brita filter? Do I have to put something in my water heater or my well? Like, what do I need to do? Right? Do I need some other like water softener to get put into my system? I don't know. Okay. So the analysis gives them the remaining results or takes the results to one step further. Okay. What does that mean to me? All right. But for most of our labs, we're not going to have that fourth part. Okay. The data, the conclusion of your calcium chloride is 30%, my unknown was 30% calcium chloride. There is no other meaning to this. It doesn't mean anything to us. So there's no further analysis to be done. Okay. So, but these are the 4 steps that I generally drive home when we're writing our conclusion. Okay. So here's what it would look like. I don't know why there's some weird artifact in there. So this is a conclusion from the hard water lab. Okay, the purpose of the experiment was to determine the calcium content of the water, that we refer to as water hardness. The water samples were tested using pH titration. The titrate used was ethylene diamine tetracemic acid, or EDTA, which is first standardized using a 200 ppm calcium sample. EDTA prepared in a concentration of 0.012 based on an average of 3 samples, and it was further titrated and the calcium concentration was 65 ppm. The value according to the EPA water is moderately hard. Okay, so in my 4 steps, okay, we have the purpose, the general methodology, okay, what was the result, and what does the result mean? Okay, so and again, there's like many steps that went into this as far as the procedure and everything, but we don't, there's 2 parts to the lab, so both parts of the lab are mentioned as far as data. So there's data in the conclusion. Okay, I shouldn't have to search to your data section to find the important pieces of information. Okay, things should be in your conclusion. Okay, reading the conclusion first. So usually when people read things like journal articles, we read the introduction, or we read the conclusion, and then we go back to the middle. Okay, so the conclusion should summarize everything that we need, everything that was the most important stuff should be in the conclusion. Okay. All right. So as a quick run through on the lab reports, okay, you have that PowerPoint. If we go over here at the, so in the lab schedule, again, the chemistry, the lab report right there. So the PowerPoint right there, that is the PowerPoint I just went through. Oh, okay, that didn't work. All right, so I got to fix those 2 pages. Okay, so I guess the sample lab reports didn't quite make it over. I'll fix that. Fix that here this morning. All right, so the sample lab reports they're just that. There's copies of lab reports that are samples for you to look at. Okay, all right. So really what we want to talk about real quick here is the pennies lab. Okay, so if you click on the Excel tutorial, right? So again, this is a summary here of what you need to do. Okay, I'm looking for 4 pages. Okay, the data page with the calculations, a year versus the average mass graph, the year versus standard deviation graph, and the conclusion. Okay, what do the 2 graphs tell us, okay, about any particular trends in the average mass of pennies? Okay, why did they change? What happened? Okay, what does the data tell us about what's going on? Okay, so in here, you'll find the Excel sheet. Okay, so the Excel sheet has the data that you need. Okay, this goes through and how to do the various calculations. Okay, what am I looking for a graph? Okay, so let's take a look here at the Excel sheet. Okay, so here you have the mass of pennies from 1971 to 1995. Okay, so if you're not familiar how to use Excel, this adds an extra little complexity in here because everything is going to be virtual, so there's going to be a bunch of Excel work that you're going to have to use. Okay, so you're going to have to figure out how to use Excel. So there's other links in there on how to do stuff. So if we just want to take the average mass of the pennies, okay, and the standard deviation of the pennies. All right, and this concludes page 1 of your report. Okay, is simply just doing the data. All right, but then you want to get an average. You want to take the year versus the average mass. Yeah. It's in the equations in the main page. I can go back to it, look at it. All right. So, all right. So here we want to insert a graph. All right, it's an XY scatter chart. All right. And so here we get our graph of the average mass versus the year. All right. Now, what you want to do is you want to make this look good. Okay. Now maybe this is where we have to work on our soft skills, right? So some of your soft skills about how do we do different things, how do we do editing in our page. Okay, again, these are things that you have to learn how to do, right? And so, your graph should look and be all labeled. So there should be axes that are labeled. So if this is my my average mass, right? So you can change everything here so that everything is readable, okay? And your year, okay? Again, your graphs should look as professional as you can make them, okay? Again, they should not look like you did this on a napkin and crayon. All right. So we can talk about the how to do the Excel thing here in a minute. So let's just get through the basics here for everybody who may have some general understanding of how to do this, and then we'll go from there. Okay. Right? And so this would be your second page, would be the average mass versus the year. So it should look nice, and so you want to clean everything up. And so this would be what you would put into your Word document. Okay, and so then you would repeat this for the standard deviation, and then we'd write a conclusion. What does that data mean? Obviously, you just saw a trend occur there. What does that mean? How did that happen? Okay, what does the standard deviation graph tell us? Okay, how does that work in relation to the other graph? What information is being correlated between those two graphs? Okay, so your conclusion is summarizing what you got from the data, from the two graphs. What does it mean? Okay, this does have some analysis. What does it mean? Okay, just telling me that the mass changed. Obviously, the mass changed. You just saw a picture of it. Okay, what does it mean? How did it happen? Okay, why? Okay, when, how? Okay. Conclusion is paragraph giving me as much information about what happened to the mass of pennies over these years. What does the information tell us? What does the graphs tell us? Okay. You got to tell me about what the graphs are telling you, right? Because that's where the data is. Okay, we're explaining what does the data mean. Now there may be other sources that you have to look up to do further analysis. Okay, we don't ever do analysis in a vacuum. Okay, so 4 pages. The data page, what you see right here, 2 graphs, 1, 2, average mass versus the year, standard deviation versus the year. Conclusion. Okay, 4 pages submitted to the so when you look at the main page, then So the submission links should be at the bottom. Go back over here. Okay, submission links. Okay, so this is the bottom of the lab page. Okay, there's the lab page. So everything you need will be down here at the bottom. So you can submit these labs, all right, down here. So each one of these labs is going to be due the week after we have our meeting. Okay, so this is due next weekend. Right, so next Saturday, this lab is due. We're going to talk about the physical properties lab next week. And then that is due the week after. Okay, so you have 1 week to do each lab. Okay, you have a little bit more probably in one of these other ones. Okay. And so this is basically what we're going to do when we have these lab meetings. Okay, is I'm just going to go over what it is that I'm looking for. What do you need to do for the lab? What am I looking for you to submit? And then you guys have all the data, you have all the rest of the information, and you can go forward with that. Okay. So now I scheduled an hour. Okay, so I schedule an hour for each one of these meetings. Okay, so here's the other things that we can continue to do. All right. Now, after I get through just the bare bones, this is the lab, this is what I'm looking for, this is what I want you to turn in. If that is sufficient for you, you are free to go. Okay, we're pretty much done with the stuff that you need in order to carry out the lab. Okay. Now, if you want, we can stay on. Obviously, there are some questions about how do we do the Excel work, right? So I can go over that next. I can talk about some of the lab stuff. I can talk about how to do calculations. We can go through things, right? I will also be having 2 1-hour office hours during the week that'll be on Zoom. Okay, so I will post my office hour Zoom meeting invite to the lab page. Okay, so I'm going to create some sections here. So there'll be an office hour that I'm doing the office hour for my 111 class, but obviously you guys, I have you guys as well. I have a 112 lab as well. So you guys are free to join into the office hour Zoom meeting that I'll have twice a week. And I'll do them at different times, so there'll probably be different times throughout the day, during the week. So it'll probably be something set like 1 to 2 o'clock or something like that, or 1 in the evening. Okay, so you can join in one of those and ask questions if you have problems during the week. Obviously, you can email me. I check the email every day. Like I said, if you want the videos for the 111 lectures, which I cover a lot of the same stuff. I cover a lot of the same chapter material that you're doing right now. So I have lots of videos on that stuff, so you guys can have that link as well. Okay. All right. So that's pretty much everything that I wanted to cover as far as the lab content. Like I said, I try not to take up the whole time with just what do you need, the bare bones stuff. If you want to hang around, we can talk about how do we solve math problems in Excel. Okay, how do we do graphing in Excel?